Hi everyone, welcome back. Today we are going to be moving on to our 7th grade math unit 8, lesson 6. And this lesson is all about comparing data sets to draw conclusions. So before we get started, just want to double check that you have all the materials you need, just like every day. So remember, today you need a paper or notebook to take notes in. You need your classwork on Google Classroom that your teacher set up for you. You need a pencil, and then you're also going to need that online calculator or real life calculator, whichever one works better for you. You should have your notebook paper set up like mine is here with the date, Unit 8, Lesson 6, and then the title of today's lesson is Comparing Data Sets. Take the next 30 seconds to set up your classwork to make sure you're ready to go. Okay, let's do a quick review. So this unit, we've been talking a lot about different statistical measures. We started with learning about statistical measures of center, and there were two different measures we learned about. The first one was the average or mean, and the second one was the median. From there, we moved on and we started learning about statistical measures of variability, which is also related to consistency or the spread of the data. We started by learning about the overall range of a data set and the interquartile range for a box plot. And then we also learned more recently how to calculate mean absolute deviation or MAD. All three of these are measures of variability or consistency. And over the course of this unit, we've also learned a variety of different ways to actually represent our data, from dot plots, which we've seen, to line plots, which are very similar. You've also seen data sets represented in tables, and then we had a whole lesson where we learned about how to represent data with box plots. You're going to now start seeing data in a variety of different ways. So you might see information represented with a line plot versus you might also see it represented with a dot plot. You should be familiar with all of these and feel comfortable analyzing each data set. So our driving question for today's lesson is, what are the ways in which we can compare data sets to draw conclusions? And as we dive into this question, you might be thinking, well, why does it even matter? And so I want to draw some real-world connections for you to see the purpose of comparing data and why it actually matters. So for all you sports fans out there, statistics is used a lot in sports to compare different players and decide who's the best player, especially when teams are trying to decide if they're going to trade for anyone. So here you can see a comparison of LeBron James and Steph Curry, and you can see some of the different average stats that they have in basketball. So here you can see their average rebounds, also their average steals, assists, blocks, and total points they've scored per game. And calculating these averages, which we're learning to do also, helps to be able to efficiently compare players. Another real-world example is in teaching. So as a network and as at our schools, we use your data from your different assessments to figure out, on average, how much kids are growing year over year. Here you can see data for all 4 grades in math, all 3 grades, 5th through 7th in math from last year, and then also from this year. And that allows us to make year-over-year comparisons in a really efficient way to figure out what we need to do to drive our math program forward. Another example is when it comes to developing products. So something you might consider when you are going to buy a new phone potentially is how much battery life your phone gets. And here you can see the average battery life for different phones, and it allows us to quickly rank the phones to see which ones have a longer battery life. So those are some real-world examples. And now we're going to move into some math problems. So your think about it question, sunflower farmers are always interested to see how high their plants grow. A tall plant indicates great health in the flower. The dot plots show the heights of sunflowers grown in 2 different plots on a farm measured in inches. If you were the farmer, which group of flowers, plot A or plot B, would you decide is healthier and why? Take a second to just look over those dot plots. And now we're going to look at 2 different student responses, okay? I'm going to read them out loud, and then you're going to have the chance to evaluate which one you agree with. First, make sure you're just listening to me reading each of the responses. Student 1 says, I believe the plants in plot A are healthier because plot A had the plant with the highest height of 31 inches. Student 2 says, I believe that the plants in plot B are healthier because the range of heights for plot B was 26 to 30 inches, whereas the majority of plants in plot A actually grew to a lower height of between 24 and 27 inches. Your question right now, which is question number 1 for the video, is which student, student 1 or student 2, do you agree with and why? Your teacher is going to pause the video and you're going to have 2 minutes to type your response to this question now for video question 1 in your Google Classroom classwork. Go ahead and pause the video now. All right, let's go over your answer to this question and compare it with the exemplar. So if you selected student 2 as being correct, then you were right. Student 1 is not right, and we're going to take a look at why this response is not correct. When student 1 was working on their response, they actually saw 31 and they were like, whoa, this is the highest height of a plant that you can see in either of the 2 plots. And so that must mean that plot A has the healthier plants. However, this data point, the 31 inches in plot A, is actually called an outlier point. And this is a term you might be familiar with. This is a point that's actually not representative of the data set and is instead an extreme. You can see here that for plot A, most of the points are actually between 24 and 27 inches, and this 31 inches is all the way over to the right, and so it's an outlier. This data point potentially skews the data and makes you think that the plants in plot A are actually taller than they are because it's such an extreme. But because of this outlier, student 2 is actually correct in this case, and the healthier plants are likely to come from plot B. So this leads us to our first key point for today, which is that we can compare sets of data visually. We were able to compare those 2 data sets without doing any actual math, but we have to be careful with any outlier points that could skew the data. You can go ahead and make sure that this is in your notes. This is our first really important key point for today. Okay, now let's move on to a second example with the same problem. Let's say you have the same problem, right, where you're being asked, if you were the farmer, which group of flowers, plot A or plot B, would you decide is healthier? But instead of solving your answer visually now, you want to actually prove your answer mathematically. I did this work for you so I can show you how you would do this. So let's take a look at this work. So when I went to solve this problem mathematically, I thought about using a measure of center when I was going to support my answer, and also a measure of variability, okay? So first thing I did was I redrew the dot plots for myself so I can more easily work with them. And I decided that I was going to use a median instead of mean as my measure of center. The reason why is because I know that for plot A there was an outlier, and the better measure of center when you have an outlier point is actually to use median, which is the middle value, remember. So I went ahead and I calculated the median for plot A, which was 25 and 5/10 inches, and the median for plot B, which was 28 inches. That's where I started. Then I decided to use the MAD as the measure of variability in this case. I could have also used range, or you could use both. In this case, I decided to go for MAD. Remember, for MAD calculations, we first start by finding the average. So for plot A, the average was 26. Then I find the distance of each point from that average and take the average of those distances, and I ended up with a MAD of 1.1 6/10 in this case. I repeated the process for plot B, and I got a MAD in this case of 1. So now that I've done all my calculations, you can see that I started comparing the data off to the right-hand side of the screen. So looking at the medians, I can see that 28 is actually greater than 25 and 5/10, so plot B has a larger median height. Then looking at the MAD, I can see that 1 is less than 1 6/10, so plot B has a smaller MAD, indicating that there was actually more consistency in the heights of plants in plot B. Once I've done all of these calculations, I'm ready to synthesize, which I'm going to read out loud for you here. If I was the farmer, I'd say the plants from plot B are healthier for several reasons. First, the median height for plot B was larger than that for plot A, 28 inches versus 25 and 5/10 inches. Second, plot B had a smaller MAD of 1 versus that of plot A of 1 6/10. indicating there was more consistency in the heights of the plants in plot B. For those two reasons, I would say the plants in plot B are healthier. And all of this work leads us to our second key point, which is that we can compare data sets mathematically using measures of center, such as mean and median, and measures of variability, such as MAD and overall range and IQR. So we have these two ways of comparing data now, visually and also mathematically. Okay, now it's your turn. So we're gonna take a look at a second problem. I'm gonna read the problem out loud first. The double box plot below shows how long it takes employees at Target to get to work, comparing those who travel by car and by bus. This is your first question. I'm gonna read it out loud, or sorry, this is your second question. I'm gonna read it out loud for you. Question 2, which mode of transportation is more reliable? Explain. Before we actually go to do the math, I want you to make a prediction based off this visual box plot. In the chat feature on Zoom, I want you to chat which mode of transportation just visually do you think is more reliable. You're gonna put bus or car. Take the next 30 seconds to do that, and your teacher's gonna cold call on someone to actually share their response to this prediction. Go ahead and do that now. You can pause the video here. Okay, now that you've made a prediction, we're gonna move on and actually do some math, okay? So you're gonna take the next 2 minutes and you are going to type your response for the video to question 2 now in your classwork on Google Classroom, and you're gonna use one of the mathematical measures that we have to actually answer this question of which mode of transportation is more reliable. Go ahead and take the next 2 minutes, pause the video now. Okay, let's debrief this question. So the first thing I notice when I'm looking at this question is that it has the word reliable. This tells me that we're talking about consistency here. And so the next question I ask myself is, what are the best measures of consistency given the data? Here we're working with a box plot, so I know that I can use both the overall range, but also the IQR. So I went ahead and I made a table here of the IQR and overall range for both the bus and car. And I had to kind of estimate for some of the values because it's falling between 2 points on my graph. For the bus, the IQR is about 7 and the overall range is 20. And then for the car, the IQR is about 3 and the overall range is 9. Now that I have this information, I'm able to synthesize my response, which is the car is more reliable as evidenced by both the IQR and overall range. In both cases, the IQR and overall range for the car transportation times was smaller, indicating there was less variability and therefore it was more reliable. All right, let's move on. Same box plot that we're going to be looking at, but now we're answering a different question. So question 3 is, which is the faster mode of transportation? Before we actually go to solve this, same process, we're going to actually make a prediction. Take the next 30 seconds to actually enter a prediction into the chat box on Zoom. Which is the faster mode of transportation do you think, just visually based off of this graph? Your teacher's going to pause the video and you're going to enter your prediction into the chat box now. Go ahead and pause the video. Okay, and now that you've made a prediction, we're actually going to type out our responses and use some mathematical reasoning to support our answers. So you're going to have the next 2 minutes. You're going to type your response for video question 3 now in your classwork on Google Classroom. Remember, question 3 is, which is the faster mode of transportation? Pause the video now. You have 2 minutes in Google Classroom. Okay, let's debrief this question. So the first thing I notice when I'm looking at this question is that it's talking about which mode of transportation is faster. This is asking about a representative value or measure of center. So then I have to ask myself, what is the best measure of center given the data? Well, here I'm working with a box plot, so the only measure of center I have available is actually the median. So I'm going to compare the median values. For the bus, the median value was 17, but for the car, it was 11 minutes. This allows me to now synthesize my response. In this case, we're measuring the time to get to work, so we're looking for the smaller time as corresponding with being faster. The car has a smaller median transportation time than the bus, so it is the faster mode of transportation. Okay, now that you've had some time to practice, you're going to move into some independent practice with your classwork. And here are the thinking jobs I want you to be asking yourself as you get into this practice. The first question you should be asking is this question asking me to compare a measure of center, in which case I can use mean or median, or variability, in which case I should use MAD, IQR, or overall range? Second question that you want to be asking yourself that we discussed earlier on in the video is, are there any outliers that could potentially skew the data, and therefore should I make any informed decisions? And then the last question you want to be asking yourselves is, how can you support your response using both the visual comparisons we discussed, but also the mathematical comparisons? You are going to be working on classwork problems 1 through 7, and then you have an exit ticket that is 2 problems. Good luck, and I hope you do an awesome job.